everyone, and welcome to the MAT 211 review on constrained optimization. My name is Julia, and I work for the tutoring centers at ASU. So suppose that we have some function, f of x, y, equal to 9x plus y squared, or 9x squared plus y squared. We want to find the minimum of the function f, subject to the constraint x plus y equals 5. And we're going to use the method of Lagrange multipliers. So what does this mean, using the method of Lagrange multipliers? What we want to do is we want to compute some function, we'll call this L of xy, which equals our original f of xy minus lambda, which is our Lagrange multiplier, times g of xy. Now g of xy, this is our constraint rearranged so that it is equal to 0. So for instance, for our case, we have x plus y equals 5. Well, if we just subtract the 5 over to the other side, this gives us x plus y minus 5 equals 0. And this is going to be our g of xy. Then what we want to do is take this resulting function and we want to take the partial derivative with respect to x, the partial derivative with respect to y, and we're going to solve the system where L of x equals 0, L of y equals 0, and our g of xy also equals 0. So let's start by finding our function L. We'll erase these for the time being. So we have f of xy is 9x squared plus y squared. And then we want to subtract lambda times our function here, x plus y minus 5. So if we go ahead and simplify that a little bit by distributing our lambda, we have 9x squared plus y squared minus lambda x minus lambda y plus 5 lambda. So now we want to go ahead and compute our partial derivatives of L with respect to x and y. So for L of x, we have 18x. We'll skip our y squared because that'll go to 0. And then we have minus lambda for our negative lambda x. And then the rest of these terms will also go to 0. Then we have L of y, our partial with respect to y of L. That's going to give us 2y. And then minus lambda. And the rest goes to 0. So let's look at this. We want to set these equal to 0. And we also have this original function here, x plus y minus 5 equals 0. And we want to solve this system. So how can we do this? Well, we want to eliminate at least one of these variables. So let's start with maybe our 2y minus lambda here. So we have 2y minus lambda, and that's equal to 0. So we know that lambda is equal to 2y. So we can substitute this into our first equation. This gives us 18x minus 2y equals 0. Now we also have our second equation here, which let's go ahead and rewrite that as x plus y equals 5. And we can then use substitution or elimination, whatever we like, to go ahead and solve this for one of our variables. So let's go ahead and multiply our second equation by 2. So this gives us 18x minus 2y equals 0 on our top. And there's supposed to be an x there. 2x plus 2y equals 5. And we can add those. That gives us 20x plus 0 y, since our y terms cancel out here, equals 5. So therefore x equals 5 over 20, which is also equal to 1/4. Great. So now that we have an x value, we need to find the corresponding y value. So let's clean up a little bit here. And we'll just go ahead and substitute our x, which is x equals 1/4, into our third equation here. So we have 1/4 plus y minus 5 equals 0. So that's 1/4 plus y equals 5. And so 5 also equals 20 over 4. So then if we subtract our 1/4 here, that gives us y equals 19 over 4. So our y value is y equals 19 over 4. So now we want to compute the value of our function f of x at these points, and that'll be the minimum of the function in this case. Let me erase a little bit here, make ourselves some room. So we have our function 9x, so 9 1/4 squared, plus y squared, which will be 19 over 4 squared. And that is going to equal, we'll have 9 times 1 over 16. And we'll have, check on my calculator here, I can't do 19 times. Or 19 squared in my head. So that'll be 361 over 16, which equals 9 over 16 plus 361 over 16, which equals 370 over 16. And this is the minimum of our function, our minimum z value. Great. So that's it. And let me clear my screen here so I can give you one last message. If you would like to get any additional tutoring or academic support services, you can check out our Tutoring Center's website at tutoring.asu.edu. That's this guy here. And you can use the tutor search tool, which you can find either at the main website here or by going to this full link to find a tutor and our tutoring services for your specific course. So thanks so much and have a great rest of your day.